Alright, this video here is going to look at finding the graph of our derivative f prime of x given the graph of our original function f of x. So if you notice over here on the left we have our original function f of x, and our graph kind of looks like a W here. And this one's going to be multiple choice. So we want to see which one of these graphs over here at the right would be the graph of the derivative of this function on the left. So at this point, if you'd like, you could pause the video and see if you can determine which one of these three graphs is going to be the graph of the derivative of the function over here on the left side. All right, to start off, let's look at our function. Well, if we go from left to right, we know that here, as we go down, at this point, what's going to be our slope? Well, we know our slope is going to be negative. So that means the derivative is going to be negative. Okay? And then at this point here, what happens? Well, here we're going to have a horizontal tangent line. So at this point, our derivative is going to be equal to 0. Okay? So let's see, before we go any further, let's go over here to the left and see what we can determine. If we look at our graph here on the left where it's negative, it looks like it's the derivative is going to be negative pretty much until we get down to this here is a -1, so somewhere maybe negative 0.8 or so. Well, this first graph, notice here, this part of the graph is above the x-axis. So what this tells us here that the derivative is positive. Well, over here we know the derivative must be negative, so that eliminates this graph. Now, if we look at the second one here, we notice that at this point here, our derivative is negative, correct? Because it's below. Okay, now keep in mind, over here, we're not looking at the slope of this. This is telling us we're looking at the y value. Because this part of the graph is below the x-axis, our y value is negative, which tells us that over here, where the derivative is the slope, our slope is negative all the way along here until we get to this blue dot. So that means the graph of the derivative must be below the x-axis until we get to this point here. Well, if we notice here, it's a greater than -1, or negative maybe 1.3. This portion of the graph here actually goes above where it is positive. Well, our graph isn't positive until where? If this is a -1, not quite, maybe a negative 0.6. So here, that would eliminate this as being our graph of the derivative. So that leaves us with this example here. So this must be our answer. Well, we know it's multiple choice. We could just say that's the answer, but let's kind of look at this in a little more detail so we can explain why this is the graph of our derivative. Well, once again, we said over here on the left, as we go down, we have a negative derivative. Well, that's this part right here. This part is negative. Okay. And again, right here about a negative 0.6 or so, what happens? Here we have 0. Okay, and I'm going to try to color coordinate this for you. Over here, that tells us our derivative is 0. So that means we're on the x-axis. Our y value then over here is 0. All right, then over here, what happens to our function? Our graph goes up, so therefore we have a positive slope. So that means the derivative must be positive until here, your derivative, once again, we have the horizontal tangent line, so the derivative is going to be equal to 0. So right here at 0, our derivative is 0. So over here, we can notice the graph at 0, our derivative is certainly 0. And if we notice, roughly from this negative 0.6 to 0, we said we had a positive slope because our graph was increasing. Well, over here, notice all the way to 0, all of this is positive because this is above the x-axis. This part here was negative because it's below the x-axis. Okay, so again, if you follow here, the black part in negative, that's our slope being negative. Then the blue dot represents the slope or the derivative being 0. And then the red line indicates our slope is positive, so the derivative is positive. If our derivative is positive, that means this red part on the graph must be above the x-axis because it is positive. And then the green dot over here on the left, we have a horizontal tangent, so that means the derivative is 0. So that means our green dot for the graph of the derivative would also be at 0 on the x-axis. All right, then over here on the left, our graph then switches and goes down, so that tells us here the derivative is going to be negative, and it's going to stop being negative at this point here, roughly. That's where our graph is going to change directions. So let's see. That means here, again, we have a horizontal tangent line, so that means our derivative would be 0. And that occurs, what? Again here, roughly, less than 1, so maybe at 0.6 or so. And if we notice over here, we do have our graph crossing the x-axis at 0. And again, we said from 0 to this 0.6 is going to be a negative slope. And if you notice over here, the graph is certainly below the x-axis, indicating a negative slope. And then if we go to the right here, our graph continues to go up. It's increasing, so therefore we have a derivative that is positive. So over here, our graph is above the x-axis. All right, so let's look at this again a little bit closer. If you follow, I'm going to compare each one again. Well, one thing to point out, we know that here at the blue dot on the left, we have the blue dot, the green, and this real bright green. We have a horizontal tangent line, which here at these 3 points at our horizontal tangent, our derivative is going to be 0. So the blue and the 2 green dots here are going to be where we cross the x-axis. So at the blue and the 2 greens, our derivative is going to cross the x-axis because it is 0. And if we look at the first part of our graph that's in black, we have a negative slope, so therefore that part of the derivative is going to be below the x-axis because it's negative. Then at the blue dot over here, we switch and we have a positive slope because our graph is going up. So that means that part of our graph is positive, okay? Even though we have this curve here, it's positive because it's above the x-axis. And then we hit our purple here, and it's going down on the graph, so therefore we have a negative slope. So that means that part of our graph over here is going to be negative, so it's below the x-axis. And then again, our graph switches directions and goes up, so we have a positive slope, and that's why here our graph on the right is above the x-axis. Okay, this is one of those topics you may take a little bit of time to understand this. Realize that for the function, we're looking at the slope of our tangent line, whether it's negative or positive, and be careful when you compare that to the derivative over here. The derivative is negative here where it's below the x-axis, which is in the black, and over here in the purple. And our derivative is positive here. The graph is red above, and in the orange, that's above the x-axis. The easiest thing to keep in mind is when you have a horizontal tangent over here at the blue and these two green dots, that's where you're going to have a blue and green dot. That's where your derivative is going to cross the x-axis because the slope or the derivative is equal to 0.